Hi everyone, welcome back to Geeks for Geeks. Today we have another DSA mock interview, and our guest for today is Saurabh Jain. So I'll be interviewing him. I'll be asking him two or three questions in a span of 45 minutes to 1 hour. So let us quickly call our guest for today. Hi Saurabh, how are you?
Hi, yes, I'm fine. And what about you?
I'm also fine. Can you please quickly introduce yourself to the audience?
Yeah, so my name is Saurabh Jain, and I'm currently pursuing my BTech from MIT University in Noida. I'm currently in the final year, and I have done a couple of projects in the full stack development using Python, Django in the backend, and HTML, CSS, and the JavaScript in the front end. I have done 400 plus questions on the Geek for Geek, and also my hobbies are to playing badminton and listening music. That's all.
Okay. How excited are you for this interview? Are you excited or nervous?
Yeah, I'm excited for this interview.
Okay, so if the audience can hear me, so they can give us a they can give us a +1 in the chat, and make sure to give the video a like so that we have a head start. So Saurabh, one second, I'll in the private chat I will be sharing a Google Doc link with you. Can you quickly share your screen first of all? Like
Just a
they
second.
just down there you will see a option for sharing your screen. All of you can give us a +1 if my voice is clearly
Yeah,
audible and everything is fine. So you can share your screen.
yeah. Is my screen visible?
Yeah, now it's visible.
Yeah,
So once again, in the private chat, I'll share you the link. So I've shared the Google Doc link with you in the private chat. Can you please open it?
yeah.
Okay. So let us start with the first problem for today. So okay, so the like the first problem says that you will be give a celebrity. Basically, a celebrity is a person who is known to all but does not know anyone at a party. Okay, so there's a party. There are suppose n people are there. Okay, so a celebrity among those n people, a celebrity is a person who is known among all. Right, everyone knows that celebrity, but that
Yeah.
celebrity does not know anyone. Okay,
Okay.
and if you are at a party of 10
Okay.
people, so find if there is a celebrity inside the party or not. Okay, so what you'll be given
Okay.
for this is you'll be given a square matrix, like n cross n matrix you'll be given, which will be named as M, and using this, which will be used to
Okay.
represent the people at the party, such that suppose that if there is a row, right, let us look at the test case for that matter. So suppose there is a row I comma j. Okay, suppose there is a row I comma j.
Okay.
So for that what will happen is, if I comma j, if the row I comma j is equal to 1, so that means that the ith
Okay.
person knows the jth person. Okay, like for example, if you will see this
Okay.
the sample test case first, which is of size 3 cross 3. So in this test case, what you will observe is,
Okay.
you can observe that like cell 0 comma 1, if you will see 0 comma 1 is equal to 1, right, matrix 0 comma 1 is equal to 1. So you can basically observe
Okay.
that 0 knows the person 1. Okay, this is what it indicates. And similarly,
Okay.
another thing that has been given
Okay.
as 1 is, like, you will observe that 2 comma 1 is also given as 1, right, the cell 2 comma 1 is 1 as well. So that means that the
Okay.
person 2 knows the person 1. Okay, right. So is
Okay.
it clear? So
Okay.
basically the person
Yeah,
1 is
it's clear.
known. So in this example, if you will observe, so the person 1 is known by the 0th person, person 0, as well as the first person, right? And if you will see for the
Okay.
first person, so the first person is, like, if you will see the row for the first person, so for the first person the row is 0 0 0 0, right? You can see that the column, like the column is 0
Yeah.
0 0, like, okay. So that means that the
Okay.
first person does not know
Yeah.
anyone, and there are two other people than the first person, right? There is a person 0 and there is a person 2. So person 2 and person 0, both of them know one, but one does not know anyone, right? Because for the row
Okay.
1, every column is 0, right? So that is why one is a celebrity.
Okay.
Clear with this part? Are you clear with the test case?
Yeah. Yeah. Yes, I'm
Okay,
clear with the test
now
cases.
now talking about the
Okay.
second test case. So the second test case is 0, 1, and 1, 0. So in this case, the answer would be -1. Why it would be -1? The reason for it being -1 is because the two people at the party both know each other, right? Okay.
Yeah. Okay.
There's some noise from your side. Can you just check that?
Okay. Okay. Just a second. Just
So in the audience, is the audience clear with this question? Please tell me, guys. Is this question clear to everyone in the audience? Okay, Saurabh, statement is clear.
okay.
How many of you are clear with this problem statement in the audience? Please tell me, guys. Is everyone clear? All of you can give us a +1 in the chat if you are clear with the problem statement. Basically what will happen, you will be given a celebrity, you will be given n people, and you'll be asked, like, you have to do what, you have to check where, out of these n peoples, that whether there exists a celebrity or not. So if the celebrity, the condition for celebrity is that, please explain some examples. So you can look at the first test case for that matter. Okay, so what do you think, Saurabh? How can you approach it?
So I have a question in this, like, can two celebrity be possible in one test cases? Like, if I have two rows with 0 0 zeros, so that will be a like possible test case or not? Like that
Think
thing.
about it. Think about
If
it.
I
Can two celebrities be possible for a problem?
mm, okay, so we have a square. We have a square and we have to represent that. So
Suppose you have three people, so
I
you have a
person,
3 cross 3 grid.
yeah, yeah. Okay, so we have three of three good. So 0% knows anyone, and one person is on anyone. Okay, there is only one celebrity. Yeah, like if we have all three rows equal to zero in that grid particular, okay, there will be mi will always be zero. Okay, mi1. Okay, so that will be like condition. So, what approach I am thinking of this? Like, we have to just find 0 0 0 in a row particular. Like, there is no one in that. Like, in the question is given that, like, we have to find a particular celebrity, like, which is not known to everyone. Like, people are knowing to that celebrity, but celebrity not knowing to that people. Like here in the first test cases, zero and like first person know that not known the itself, but first person knows the
Let's
second
let's say
person,
the
and
let's say
first
the
person.
indexing starts from 0.
Okay, let's say indexing start from the zero. So zeroth people knows first person. Okay, so and
Hmm.
also zeroth people does not know the second people, but first people, like, not known to zero, not known to itself, and not known to the second people. So this will be our celebrity. So what I am thinking right now, can we just find a row where we have the count of 1 is equals to 0? Like, we iterate from the rows, and we then counted that, like, yeah, we have, if we have count of 1 is equals to 0, then it would be a like possibility that will be a celebrity.
Uh,
That's
so
what I'm thinking.
can you tell me, will there be just one celebrity in the in a given relationship, or there can be more?
I think a celebrity is known but unknown on celebrity. If you go to another, if you find a celebrity, a body and not okay, represent the people etc. If celebrity will reset one, like, there might be a possibility. I think there will be like one or more celebrity.
Can
Like
can you
what?
tell me a test case?
What will happen? Let's suppose we will take this test cases 0, comma 0, 0, 1, and 1, 0. Okay, so if I make all rows equals to 0, okay, let's suppose we just make, I think, let's suppose we make 0 and 0. Okay, and the another row is also 0 and 0. So in that case, the 0th people doesn't know like the first people, and first people is also not known to the 0th people. So that be might be a case of two celebrity, I think.
Did you read the problem carefully? What is the condition for being a celebrity?
A square is used to represent people,
A celebrity
parties,
is a
other if
person
it were.
who is known to all but does not know anybody.
Okay, known to all. Okay, that's, I think I'm missing. Means that person is not okay. Every person is not, is every person is knowing to that. Okay, so that might be not like not valid test case for this question, I think. So what approach I am thinking of this, um, 0th person and did not know the 0th. Okay, so there might be like, if we have count of 1 equals to 2 people. Yeah, if we can do one thing here, we can traverse through like a column by column. Okay, like from this 0, 0, and 0. We can check if the count of 1 is like
But
n equals to n
still,
minus
you
1.
have not answered me this thing. That whether they can
Yeah,
exist one or more than one celebrity can exist or not.
more than 1, I think if we make task cases 0, if the first person is known to this. Okay. Okay, and let me just go 0 this 1, and the second person on to the first, second person on to also the first this. Uh, think onto this because this is not this to this. If I make it equals to 0, then 0, 0, the person. Uh, no, I think that not be possible because if there are two celebrity like so that condition not fulfill like the every person accept the celebrity known to that celebrity. So I think the two celebrity might not be possible for this question.
Basically,
Yeah,
they'll be just one. Either they will be a one celebrity, or there will be no celebrities at all.
or yeah,
How can you have
yeah,
two
yeah,
celebrities? Because if you have two celebrities, so that means there will be two rows
yeah.
that will be zero, and that is not possible.
Yeah, yeah. Yeah, for this case, like I'm thinking zero,
Okay,
zero, and 0. So, like, if we have like a no, like first person is not knowing to everyone, and 0 also like this first person is not known to everyone, but the last person known to first, second, and like each number. So I think that will be not passing this question because there is a question condition like the all peoples are known to celebrity. If I will assume this will be a celebrity, but this first person didn't know the 0th person. So I think there will be only one celebrity. There will be no two
okay,
celebrity.
okay. So
Yeah.
this question is clear. How would you approach it? Like, can you think of some solution for it? If you have been given this matrix, how can you find the solution?
Mm, the approach I am thinking of column like I can traverse from the columns like 0, 0, and 0. Okay. If I get the count of 1 is equals to n minus 1, um, yeah, n minus 1, then I will make sure that, yeah, this will be a celebrity. Okay. But in this test case, the count of 1 is equals to n minus 1, but there is also one thing. Okay. Okay, so in that case, there will be no celebrity. So I think from checking the column wise, I can do that.
uh, but your solution, like approach, is not that clear.
Okay, let me just take it as case. Okay, what I am thinking for the project, let's suppose we have this test case 0, 0, 0, 1, 0. Okay, and another test case is 0, 0, 0. Here test case is 0, 0. Okay, so in this test case, n is equals to the 3 above the same test case. So what I am doing, I just using the like two loops. Okay, first loop for iterating through all columns. I will iterate from all columns, and the second loop, the J will iterate from like this 0, 0, and 0. Okay, I'm iterating through column wise. Okay, so what I will do, I will count the number of one in the column. Okay, let's suppose here the count of one is equals to 0. Okay, so that will be not possibility, like this will be a celebrity. Okay, so that this is clear that 0th person is not a celebrity. Okay, now comes to this column 1, 0, and 1. Okay, so here the count of 1 is 2, which is equals to n minus 1. N minus 1 is equals to 2. So we can like have a possibility that this first person like might be a celebrity. Okay, so now going to this last person, second person. So here again the count of 1 is equals to 0. So we show that this will be a celebrity. So this is I'm thinking.
Okay, so can you write the code for it?
Yeah. So let's take
One second. In the
for
private chat, like in the chat, I'll be sharing with you a link. One second. So in the chat, I've shared with you a link, so you can open it.
again. I think
This, yes, this link only.
okay. This.
You can open the editor, full screen.
Yeah. Okay. Yeah. So what I will do
Can you
for
just zoom in a bit?
me. This is
Okay, fine, fine.
now it's okay.
Yeah, fine.
Yeah. So what I will do, I will firstly iterate through columns, range m, right? It's a m. Okay. And we have also for range. So what I will do, I will check in the columns. Okay. So that's first we have that will possibility that will not work. Okay. That's for flag is equals to false. Okay. So and count equals to 0. So if that m of I comma j equals to 1, I will increment the count. Okay. If count is equals to n minus 1, not flag. Count is not equals to minus 1, not flag. And I will make flag is equals to true. Not flag. So I will make it true. If else print written the simple minus and minus 1, and what we have to return So
Basically, what
we
you will
have
be
to
returning,
return
basically
that
you have to
that
return,
person.
like if it exists, then you have to
Yeah.
return that person. Otherwise, you have to return -1.
Okay, I have to return person. Okay. Hmm. So for that,
What is the time complexity of your code?
it will be like n square because I'm using two loops. So this will give the time complexity of n, and also this will give the time complexity of n. So this will be n square is equals to -1. -1, then it will make equal to I. Like that was okay. Like I think it will be iterating from zero, then that will be like this thing. Okay, so it will return -1, and I will return here return flag. So can I submit this code?
You can try to compile it.
Okay, try to compile it. It is giving
Does it work on the
accept,
samples?
accepted outcome. Yeah,
Okay,
it's
you can
work on the
submit it.
samples.
You can submit it.
It fails. Depends.
Okay,
Minus.
can you think where your approach is failing? Because there are two concerns with your approach, right? First of all, it's not correct.
Yeah.
Although it's order of n square, still it is
Okay.
not correct. And the second thing is it's taking
Yeah.
a lot of time. It's taking order of n square time.
Yeah. Yeah. So for making correct, we have to like zero person onto that celebrity. Zero first person onto person also, and first person is also not this also. I can just think of that. Zero, 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 one, zero. Okay. So this I'm doing. The person knows to the both element. If that person, particular person, they don't know the everything. Like I will not do this. Yeah. This. Okay. That thing I can do. I will find true count is equals to zero. Then I will search for it. Uh, okay. Uh, one approach like correction. One other approach I am thinking like. Firstly, I will find like there is any row of 0, 0, and 0. Okay, so that I'm here. I'm 0, 0, 0. So now then I will check the column. Okay, so if the column count of one is equals to that like n-1, then we can declare that celebrity is then this is a celebrity.
And how much time will that take?
Mm, for counting in square for this, and I think for searching this particular row, like if we want to search it, that row is equals to count is equals to of one is equals to zero. I think that will be like n square again.
Okay.
Yeah, for this. Yeah.
So you can try to implement it. Let's see what happens.
Okay. So for the improvement, what we can think, okay, zero, 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 zero. I'm also thinking to optimize it to zero, zero, zero. What traversing is like
I can see a
better
lot of
here?
people are
That
watching us, so all of you can make sure to hit the like button, guys, and comment down a plus one.
okay. So for the optimization, like I don't able to think that like what kind of optimization we can do to make it n square to n. Can till now I think I'm able to like think of n square approach for this question
So currently, you are not able
for
to come up
finding
with an
that
order of
zero
n
zero
approach.
order of n approach. We can get this zero zero zero. That will be a celebrity. That will be again n square if we didn't find it. No, I'm not able to think that n complexity. Zero.
Okay, so
Yeah.
can you just implement this order of n square if you can? That you were saying.
Yeah. Yeah. So check. This equals to I particular. Okay. So, then that will be celebrity. Okay. For I in range again. Everyone. Right. So I have to just check that if particular. Okay. So range and equals 0. Okay. In flag is equals to 1. But not I can't do that. There will be a 0 that it might be a change is equals to n minus 1. Then it will return that flag. I, yeah, it's accepting. Hello.
It is accepted, but what is the
Yeah.
time complexity of your
Yeah.
approach?
Like if I include this m dot count because it will take off and complexity And also this will takes off and complexity, then it will be n square.
Okay. So can you think of optimizing it?
Yeah,
Can you think like how there's some way that you can reduce this much number of comparisons? Because you are currently checking for every row in the brute force manner.
yeah, yeah. So without checking, like, if, what is the question? It used to represent the particular, so that if an element of row I and G set to 1, that means ith person, okay, ith person knows jth person, okay, it knows to the jth person, it will also know to that person. No, I think I wasn't able to find that of and complexity for this question, because like we have to find the 0 0 and 0 sequence.
Hmm?
No, I think I am not able to like find the off and complexity way.
I'll give you a hint. Like, can you think like see? They can be various ways to optimize it. But like,
Yeah,
can you think like what element? Like, see, see. Ultimately, what you want is you want to check whether there exists a celebrity or not, right? So if you want to check for that,
yeah, yeah,
so I'll give you a hint that if you keep on comparing two people, let's say what you have is,
okay,
let's say you have zero, like for the first test case, let's say you have person zero, one and two, right? So if you
yeah,
keep on comparing two people at a time, let's say you compare zero and one. So if zero knows one,
okay.
so will zero be a
Hmm.
celebrity?
If 0 non 1, no, not, it will not as like a celebrity because it known to that person.
Okay. And so in that case, what
Yeah,
you will do is maybe you will compare further one and two. Suppose what happens is suppose one uh, knows let's say one knows two. Then what will happen? Like suppose one does not know two. So in that case, what will you do?
one does not know to two.
See,
Okay,
we
that
were having
might
three
be a
elements, zero, one, and two. So first of all, we compared zero and
okay,
one. So when we compared zero and one,
okay.
so zero was knowing one. So zero could not be a celebrity, right?
Okay, okay, okay. That thing, like you want to tell, like we have to check only the n times. Like if zero knows to one, okay, we have to check only these indexes. If zero knows to one, then zero will not be like a celebrity. Okay, then we have to check one knows to two or not. If one doesn't know to two, that means that one will be a like celebrity. I
No,
think
one
that
can be a
will
candidate.
be,
One can be a candidate, right?
yeah. One might be a celebrity. Yeah.
Because there can be other scenarios as well. So can you think now? Can you think
Okay.
about it now?
Okay. Let me just try. 0 0 0 0 1 and 0. Okay. So we have to just 0 1 and 1 0. 0 knows one. Okay, 0 person knows the first person. Not. It's know that first person, but if the 0 knows that one person, that will be not complexity. Okay. Yeah, 0 person, 1 person, not the 0, it will be 0. Okay. Then we have to again check like 0 and 1 at a time. Okay. Now the flag is equals to p again, equals to 0. Make it here. Okay, 1. Yeah. Now we just check if 1 knows to 2, 1 knows to 2, it will be 2 knows to 1. Okay. What happened if 2 moves to 0?
Uh,
I can think of that like We just iterate through all the peoples like 0, 1, and 2, and then we check if 0 knows to 1. Let's suppose if 0 knows to 1, then 0 might not be like 0 not have celebrity. Okay, 1 might be a celebrity. Then we have to check 1 nose to 0, like the reverse of that index. 1 nose to 0, if these both condition will be true, then it will be clear that 1 and 0 not a celebrity. Okay, so in that case, like 0 and 1 are not a celebrity, but we have to again just look back for that. If we want to use if we want to for 2, like 0 nose to 2 or 1 nose to 2, for that I think 0 nose to, let me think of that. Only that optimization, no, I wouldn't able to get that simple thing. Mhm.
But are
No,
you
no,
able
I'm
to
not
understand
able
that
to get this thing.
are you able to understand
Yeah,
the process that by using this kind of a comparison, you would be able to reduce the number of comparisons that you were earlier doing now?
yeah, we can reduce the number of comparison. We can just have to check some comparisons like 0, 1, and 1, 0. So we can reduce the number of comparison, I think.
Uh, no
Like, but
problem.
what happened?
So
I have a
can you no
yeah.
problem like like maybe you're not able to come up with the optimized approach, but let's move to the next problem
Okay,
because we are running out of time. So can you just quickly scroll down?
okay, okay. Yeah,
Yeah, just open it on the newer page, like 1 second. I'll do that. Yeah, 1 second, just yeah. So now I think it must be visible to the audience as well, right? Yeah. So let us do this one. So you have some idea
okay.
about trees, right?
Yeah, yeah,
Yes or no?
yeah,
Okay.
yeah. I
So
have idea about trees.
okay, so let's quickly read this problem as well and see what it says. So you have idea about binary
Okay.
trees? What are binary trees?
Yeah, binary is like having two nodes and one parent.
Okay.
Like
So see,
one
what
parent
you will be
having two
given is
childrens.
okay.
Yeah.
So and what is a binary search tree?
Binary search tree is like a sorting thing. Uh, like we have a parent, and on the left side we always the smaller element than the parent, and on the right side we have always greater element than the parent.
Okay. So let's read this problem up. So the problem says that you will be given what? You'll be given a binary tree root. Okay, so you'll be given a root of the binary
Yeah.
tree, and what you have to do is you have to return the maximum sum of all the keys of any subtree, also a binary search tree. Okay, does it
Okay.
make some
Okay.
sense? Basically, I'll give you the root of a binary tree, and what you have to do is you have to
Okay.
return the sum of all the elements in a subtree, which is a binary
Elements.
search tree. Okay.
Okay.
Let
Which is a
Can you
binary
just
search
move
tree.
down? Can you move down for the sample example?
Yeah. Yeah.
Okay. If you will see this here, if I give you this example, so the tree is like 1 4 2 4. So can you see can you see for this subtree that is rooted at 4, like 4 2 and 4 4, which is having a child
Yeah.
2 and another child 4, which is having the left child is 2 and
Yes.
right child is 4. So is it a binary search tree?
Okay.
Is it a binary
Hmm.
search tree? 4
I think
4 2 and 4? No.
4, 2, and 4 not, because 4 is equals to 4, that right element.
Because the what is the condition
Like the condition
that the
is that
left
if we have only yeah, the left condition will be like always smaller element, and in the right we have always greater element than the parent.
Okay, so you look at the subtree which is rooted at 5. So for 5 you have a left child as 4 and a right child as 6, correct?
Yeah, it is a binary tree,
Okay.
binary search tree.
Fi- for
Yeah.
for the subtree rooted at 5, it is having the left child as 4 and right child as 6, so it is a binary search tree. All of you can, like in the audience
Okay.
also, they can give us a +1 if they can see this. Okay, now is there another is there any other subtree? Yes. So if you see for 3, so can I say that the subtree that is starting from 3, rooted at 3, it is also a binary
Okay.
search tree because every root satisfies that condition, I think. Because if you see 3, so
Yeah.
if 3 is the parent, then its left child is 2, which is less than it, and its right child is 5,
Yeah.
which is greater than it. So fine with that. And you can see what
Yeah.
you can see for 5.
Okay.
For 5, you can see that 5 we have already seen, right? 5 is abiding by the
Yeah.
conditions, and the leaf will always be a binary search tree here, right? Individual leaves will always
Yeah.
be. So we can say that this particular
Binary
component
search.
that is there, right? This particular component which is rooted at
Okay.
3, so 3, 2, 5, 4, and 6, all these nodes, all these leaf are in a component which is a binary search tree, correct?
Binary search tree. Yeah.
Correct. Okay.
Correct.
So
Yeah. Yeah.
like, so what you have to do in this problem is, you have to do what you have to, like, see, you will be given a tree. Okay. And
Okay.
what the
Okay.
constraint is, that the thing is that when you are given this tree, so which is rooted at a particular root, we are given this binary search tree. So your task is to find
Okay.
the maximum. There can be many binary search trees inside this tree, right? So what you have to do is you have to return the
Okay.
sum of the maximum, right? You have to return the sum of the maximum binary search tree. Okay, you have to take the sum of
Okay.
all the nodes
Okay.
of that particular binary search tree, and out of those answers, you have to return the maximum sum. So you will be taking the sum of the
Okay.
nodes which are part of binary search tree, and after taking the sum,
Okay.
whichever sum is possible for a particular binary search tree, that you have to return. Any
Okay.
doubts in this
I
question?
have to return. Okay. Mm, till now, I think I have no doubts in the question.
Okay,
Okay.
can you move
So
down to the
we
second
have.
test case as
Yeah.
well?
Okay.
You can directly move down to the second diagram. Okay,
Okay. Yeah.
just scroll down now. Yeah.
Okay. This
So
one.
let's see this one. This one. So is this a binary search tree? Like for 4, you have 3, right? So that is fine. If you are rooted
Okay.
at 4, suppose
Yeah.
you check that, okay, at 4, the binary search tree, like the left child is 3, which is lesser than it. But for 3, is that the condition? Is the
Okay.
condition for binary search tree complete? No,
No.
because
No.
for
No. It's
3,
not a binary search. Yeah.
like, see, 4, starting from 4, if the root is 4, then it is not a binary search tree. If the root I say
Yeah.
as 3, then also it is not a binary search tree, correct?
Yeah. Yeah.
But
Correct.
but the leaf node individually can be said to be a binary search tree, right? Because, are you clear with this?
Yeah. 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 I'm clear with this. I'm clear with
so
this.
so the individual leaf node 1 is a binary search tree in itself, and the individual node 2 is a binary search tree
Two.
in itself. So the maximum sum is what?
Maximum sum is two.
Okay, so these kind of cases you can
Yeah.
encounter, and there can be many possible scenarios and combinations. So are you clear with the question?
Okay. Yeah. Yeah. I'm clear with the question.
So how would you approach it?
Yeah. Okay. This, I have a question. Like, let's suppose we have a test case in this. So in the left, we have like suppose this 5, 4, 6 is not a binary search tree. Let's suppose a test case. Okay. So,
So in that case, it
but
would not be a
two,
binary search tree overall.
three, two. Yeah.
Like, what do you think?
Yeah.
Like, what you are saying is that, suppose the rooted at 5, it is not behaving like a binary search tree. It is
Yeah.
not behaving according to the property. So
Yeah.
will you
Yeah.
count that segment? Will you consider that segment as a BST? What do you think?
Like if it is not behaving like a binary search tree, then I think that will not consider in that segment.
You will not consider it as a BST, so you'll not take it some.
Yeah. Okay. We will not take. Yeah, I think that I'm clear with this. Just a second.
So, like,
So
any approach comes to your mind, like how you can do it? any brute force approach or any sort of approach that comes to your mind?
So, surely I will use the recursion here, and I will go like first one by one. I will go for the left as well and the right as well. Okay, let's suppose we go to the left part in this test case. So I will go to that proper left to here. Okay, I always consider to always consider the leaf nodes. Okay, or we can stop that I can also traverse till this 4 and check if to I will take the maximum from the both. Like firstly I will check this subtree is a binary tree or not. Okay, if it is a binary tree, like it is a binary
It is
tree,
given.
binary
It is
search
given.
tree.
It is a binary.
Yeah, it
Okay,
is
binary
given a
search
binary.
tree.
Not I'm binary search. Yeah, binary search tree. If it is a binary search tree, then I will consider the whole sum 4 plus 4 and like 2. Okay, if it is a binary search tree, but let's suppose here it is given that this is not a binary search tree. Then what I will do, I will just take out the maximum from here. Okay, so the maximum from here, like let's suppose this value will be 4, so I will take out this 4 and go to this route and then again traverse for this right part. Okay, so now I will stop here at the 5 node. Then I will consider this 5, 4 and 6. Then I will check this is a BST or not. If this is a BST, then I will sum up and compare with this 4. Okay, that maximum I will store it in a some variable. So it will be sum is equals to 4. So I will take out the maximum. So 5 plus 6, 11, and 4, 15. So the maximum will be taken 11. Okay, then I will come to this 3. Okay, so then I will see. Okay, this will be a parent, so we have to include that sum there.
But
Okay,
you will check for the
so
BST condition, right? From will you check for the
yeah,
BST condition
yeah,
for?
yeah, yeah. Yeah, also for this first I will check the BST, that if it is will be a BST, then if it will be a BST, uh, then I think parents we can do
Like the
BST.
concern is to check for the BST condition. How will you keep on, like how will you always keep a track that whether the current sum that you're considering is a BST or not?
We can use this like a simple formula for checking the tree is a BST or not for the maximum and the minimum value defining. Like from here, when I will go here, I will define the maximum value will be 1. Okay, and minimum value will be infinite. Okay, so as I moved on here, so I will check that it is not a BST. Okay, so I again uh, im, like redesign the condition of maximum and minimum. I will make a maximum value I can get in this subtree will be 4 and the minimum will be infinite. Okay, so if we can take this this subtree, so what I will do, I will do here the maximum value I can get 3, but infinite minimum value I can get infinite for the left part. Okay, so the 2 is lying in the both condition. Okay, and for the right part what I will do, I will take minimum value will be 3 and maximum value will be infinite. So this 5 is also satisfying that max and min condition. So this way we can check the BST part.
How much time will you take to check for, let's say, every node or for checking the BST?
No, no. While we traversing through the through the subtree, we can check that condition side by side parallelly.
Okay, so how much overall time will you take
Like
to check whether for every node you
like
will try to check that it is a BST or not, it is able to make a BST or not rooted at that particular node. So how much overall time would you take?
okay. So it will be like the number of nodes in that sub tree. Okay, that's why one, 3, and 6, 7, 8, 9. Okay, we have 9 nodes, so it will take like of that particular n. Okay, so n will be the number of nodes in the tree. So that much time I think I will take to traverse through the each nodes and for the like checking the BST. I think.
So what condition would you write? Let's say you have to check whether let's say you have to check whether one is a BST or not. From rooted at one, whether you are able to make a BST or not. So what would you do?
Okay. So what I will do, I will declare a max variable as a infinite. Okay, and also okay. Also, a mean variable is equals to minus infinite. Okay, so I will check this then I will check this one lies in this condition or not. If this will lies in these both condition, like one is min is like greater than max. Okay, like this is the condition. We will check for the one. Okay, now what we will do, we will modify
Like what
the
is this
max
min and
min for
max?
the left. Min in max like the maximum value we can get in that particular BSC. Like let's suppose we
Maximum value where?
maximum value will be like infinite like in this particular one node. Okay, in if we have this BST, let's suppose this will be BST. Like here we have value 4, this particular first node will be 4, and here will be 2, and here 3 and 1. Okay, so in the particular BST, in this particular subtree BST, we can get maximum value to this 4. Okay, not equal to that 4 but less than this 4. Okay, and minimum value we can get like minus infinity. Okay, so then we again check this node. Okay, so we have this is equals to 2. So now we will again again like uh, redesign the max min condition, and minimum will be always infinite and maximum will be equals to 2. Okay, for the left part, and for the right part minimum will be like 2 and maximum will be infinite for this. So this is the particular like this is the simple condition for checking the BST. If you want to check that particular tree is a BST or not. Yeah.
Let's like I'm not clear with this approach.
Okay.
Like
This.
how are you updating your minimum and maximum and everything? I think you want to say something
Let me.
else.
Okay, just a second. Just a second.
In the audience, if you are I can see 100 plus people are watching us. So if you like the quality of the questions that we took today, so all of you can give us a thumbs up, like +1 in the chat, and you can like the video as well, guys. Okay, so that we can take such more mock interviews on GFG. Meantime, Saurabh is trying to come up with an approach. You can give us a +1 in the chat and make sure to hit the like button, guys. This is a request. You can hit the like button for the video if you have liked the problems that we took today.
Okay, and we have to take the sum only for the BST.
How
Am
are
I
you
right?
keeping a track of this? How are you keeping a track of the sum? All these things you skipped.
Yeah, the sum of all
You
these
also skipped.
things.
Yes.
Okay, okay. Yeah, I was like thinking of like storing in a variable, but this will create a problem for in the backtracking. Like if you want to check for this in another way, you can like think of some. This will be BST. You have to check like we have no responsibility of this. Okay. So sum is equals to 1, and if this is a BST, so this will be the BST of the nodes. Okay. What will guarantee like this will be considered as a in the PST segment or not? 2 or 4. Mm, take out the maximum. We will check that this is the BST or not. If it is a BST, we will take the whole. Okay. So, if we're going to this, we also doing this, and this will take this, and this will take the BST. Yeah, this will also take the BST. The
See
sum
the
is
basic
taken as
the
BST.
see the brute force approach for doing it. Sort of almost time is out. So I'll
Yeah.
tell you the approach. What could have been the
Okay.
approach? So basically, see the first thing that you
Okay.
could have done in this problem is you could have said that starting from a particular node, right? Starting from a particular node,
Yeah.
you could go down and keep on a check. Like you can check for
Yeah.
every node whether it is forming a BST or not. But if you check for every node, so for one
Yeah.
node, you have to traverse the complete tree. So it would take order of n time.
Yeah.
For another node, if you have to
Yeah.
do it,
Yeah.
so order of n time for that as well. So if you do it for all the nodes, it would take order of
Yeah.
n square time, and you can keep on finding the sum. But that would be inefficient because it would be order of n square, right? So the better
Okay.
approach for doing this kind of a problem is that what you can check is like if you want to check, right? So for that you need to keep a track of the maximum element at the left and the minimum two at the right. So if my maximum element at the
Okay.
left, if the maximum element in the left is lesser than the value at the root, okay, if suppose that I
Yeah.
am the
Yeah.
current root, if the maximum element in my left subtree is lesser than me, and the minimum element
Okay.
is greater than
Okay.
me, then I'll say that it is performing a BST. This is one optimization that
Yeah.
you could have tried, but I
So, like, I have a question in that approach. Like, yeah, we will check for this particular node 5, 4, and 6. Okay, we can check that this particular 5, 4, 6 is a BST or not. Okay, but what will happen? Like, if we come out to this 3, if we want to check
when
this
you come to
3 to
this
5,
see,
3 to 5. Yeah,
mhm. So see, 5, 4, and 6 is a BST. You know that, okay.
yeah, yeah,
And now
yeah.
now the answer depends on what? Now the situation depends on 3. Okay. So in the left
Okay,
subtree of 3, which is the maximum value? It is 2, which is lesser than it. And in the right subtree of 3, which is the minimum value? It is nothing but what?
with 4,
Minimum value
4,
is 4, which is greater
4.
than it.
Yeah.
Which is greater than, that's why
So,
it's a BST.
so like,
So
how
this is
we
one
will track
optimization
this?
technique.
The minimum value is
Basically,
here for.
basically the concept is that first of all you'll hit the leaf nodes, and from the while you are moving up, they'll keep on building the answer one by
Okay.
one. Okay. This was the approach, but I think
Okay.
you were not able to come up with this approach, but no issues for that.
Okay.
And talking about the celebrity problem,
Okay.
so you were able to tell about the brute force approach, and you were able to code it as well, but after some failures, and I think you could have come up with the optimal approach for both the problems, right? That was
Yeah.
good. Like, but I think that there is something you need to build a bit of more logic for cracking the optimal approaches for the problems,
Okay.
right? Although you have solved a lot of problems, but maybe there is something that
Okay.
you are lagging, because you were not able to maybe implement the brute force approach for the celebrity problem. So I will say that some
Yeah.
like some things are lagging. So I hope that you learned something from it. Was it
Yeah.
helpful for
Yeah.
you?
Yeah.
Okay.
It's like really helpful for like the experience for me.
Okay. So, thanks a
Yeah.
lot, Saurabh, for joining us for today. I hope that you enjoyed a lot, you learned a lot. Now I'll talk with the
Yeah.
audience. So thank you, Saurabh. I hope that each and every one of you liked the questions that we discussed. The first problem was celebrity problem, and the second one was largest sum BST in a binary tree. So I hope in case if you did like, so all of you can make sure to hit the like button for this video and give us a +1 in the chat if you did like it. I'm just here for 30 seconds more, and then we'll end this stream. So before we end, all of you can give us a +1 in the chat if it was helpful, or you can write helpful in the chat if this video was kind of helpful to you, if this mock interview you think was helpful to you. And apart from this, what you can do is you can hit the like button as well. So thanks a lot, everyone, and we'll see you in another mock interview. Till then, happy coding and take care.